Hello folks, Dilip Bhatnagar here. In this video, we shall continue with the integration of some particular functions. In the last video, integrals of some particular functions part 1, we learned how to find the integrals of functions of the type integral dx by ax square plus bx plus c and integral dx by root of ax square plus bx plus c, where a, b and c are constants. In this class, we shall learn how to find the integrals of functions of the type integral px plus q dx divided by ax square plus bx plus c and also integral px plus q dx divided by root of ax square plus bx plus c, where p, q, a, b and c are constants. To find the integral of functions of these types, we have to express the numerator, that is px plus q, such that px plus q is equal to a into d by dx of ax square plus bx plus c plus b, where a and b are constants. To find a and b, we have to equate the coefficients of x and the constant terms on both the sides. After a and b are obtained, the integral is reduced to one of the known forms. We will now solve a few problems which will make the process clear. The first one is I is equal to integral x plus 3 dx divided by x square minus 2x minus 5. As mentioned earlier, let me take the pen. Yes, now we have to express the numerator, that is, let x plus 3 is equal to a into d by dx of x square minus 2x minus 5 plus b. Therefore, x plus 3 is equal to a into d by dx of x square minus 2x minus 5, that is 2x minus 2 plus b. Therefore, x plus 3 is equal to 2a into x minus 2a plus b. So now we will compare the coefficients of x and the constant terms on both the sides. Therefore, comparing the coefficient of x and the constants on both sides. So on the left side, the coefficient of x is 1, therefore we have 1, and on the right side the coefficient of x is 2a, so 1 is equal to 2a. Therefore we have a is equal to 1 by 2. Now let us compare the constants on both the sides. So on the left side the constant is 3, therefore 3 is equal to, on the left side we have minus 2a plus b. So let us put the value of a in this. So 3 is equal to minus 2 into 1 by 2 plus b. Therefore b is equal to 3 plus 1, that is 4. Therefore now we can write the numerator as, that is x plus 3 is equal to a, that is 1 by 2 into 2x minus 2 plus b, that is 4. Therefore now we can write I is equal to integral. Now for x plus 3 we write this 1 by 2 into 2x minus 2 plus 4 whole divided by x square minus 2x minus 5 whole dx. Right? Now let us divide it, separate the terms. Therefore we will get that this is equal to 1 by 2 integral 2x minus 2 divided by x square minus 2x minus 5, right, dx plus 4 integral dx divided by x square minus 2x minus 5. Therefore now I is equal to 1 by 2 into I1, where I1 is 2x minus 2 by x square minus 2x minus 5. So 1 by 2 into I1 plus 4 into I2, where I1 is equal to integral of 2x minus 2 divided by x square minus 2x minus 5 dx, and I2 is equal to integral dx by x square minus 2x minus 5. Okay, now let us start with finding the integral of I1. So I1 we have is equal to integral 2x minus 2 divided by x square minus 2x minus 5 whole dx. Okay, now we know that the integral of the d by dx of x square minus 2x minus 5 is 2x minus 2. Therefore let us take x square minus 2x minus 5 is equal to t. Now differentiating both sides, we'll have 2x minus 2, right, dx is equal to dt, right? Now we can continue. I1 is equal to integral. Now this 2x minus 2 dx can be written as dt, so here we'll write dt divided by, now x square minus 2x minus 5 is t, so I get dt by 5 by t, right? So this is equal to log of t modulus of t plus the constant c1. Okay, now let us put the value of t. So we'll get log of x square minus 2x minus 5 plus constant c1, right? Now let us take the next part, I2. I2 is equal to I2 we got is equal to integral of dx by x square minus 2x minus 5, right? Now as we learned in the last class, the first step is to see that the coefficient of x square is equal to 1. So here it is equal to 1, so we can directly go to the next step. That is, in the denominator we have to add and subtract 1 by 2 into the coefficient of x whole square. So we will get this is equal to integral dx divided by x square minus 2x, right? Now what I told, we have to plus and minus half of the coefficient of x, that is 2 whole square, right? And you have to subtract the same, so this is 1 square minus 1 square, and the remaining minus 5 we write it here. Okay, now this is equal to integral dx divided by, now this particular portion I can write it as x minus 1 whole square, and this is minus 6, and then I can continue. This is equal to integral dx divided by x minus 1 whole square minus root 6 whole square, right? Okay, now I can use the standard integral, highlight in brackets. The standard integral that we are going to use is integral dx by x square minus a square is equal to 1 by 2a log of x minus a by x plus a plus c. This is the standard integral that I'm going to use. So before that, I'll have to take x minus 1 is equal to t. Therefore, let x minus 1 is equal to t. Therefore, I get, differentiating both sides, I'll get dx is equal to dt. Okay, now let me go to the next page. Okay, therefore here I'll get I2 is equal to integral. Now since dx is equal to dt, for dx I can write dt divided by x minus 1 is equal to t, so I'll write t square minus root 6 whole square. Right. So now I can use the standard form and I can write that I2 is equal to I2 is equal to 1 by 2 1 by 2a, so a is root 6, so I'll get 1 by 2 root 6 log of t minus a, that is t minus root 6 divided by t plus root 6 plus c2. Now putting the value of t, we'll get I2 is equal to 1 by 2 root 6 log of t is equal to x minus 1, so I get x minus 1 minus root 6 divided by x minus 1 plus root 6, right, plus c2. Now we know that I is equal to 1 by 2 I1 plus 4 I2. So I've already found out I1 and I2, so I can put I1 I2 here. So 1 by 2 I1 is equal to log of x square 2x minus 5, right, plus 4 into I2. I2 is 1 by 2 root 6, 1 by 2 root 6 into log of x minus 1 minus root 6 by x minus 1 plus root 6, right, plus c, where c is equal to c1 plus c2. So this is how we do the sum. Now let us go to the next sum. Okay, the next sum is I is equal to integral 4x plus 1 divided by root of 2x square plus x minus 3. As we had explained earlier, we have to take the numerator, that is 4x plus 1 is equal to a times d by dx of 2x square plus x plus b, right? Therefore 4x plus 1 is equal to a into the d by dx of 2x square plus x is 4x plus 1 plus b. Therefore 4x plus 1 is equal to 4a into x plus a plus b. Now comparing the coefficients of x and the constant on both sides, we will get 4 is equal to 4a. Therefore a is equal to 1. Now comparing the constants, so 1 is equal to a plus b. Now putting the value of a, I will get 1 is equal to 1 plus b. Therefore b is equal to 0. Therefore I can write I as integral here a into 4x plus 1 is equal to a into 4x plus 1 plus b. So a is equal to 1. So I will get 1 into 4x plus 1 plus b. B is equal to 0. So I don't need to write anything. Divided by root of 2x square plus x minus 3, right? So now I know that the d by dx of 2x square plus x minus 3 is 4x plus 1. So we can write that let two x square plus x minus 3 is equal to t. Therefore 4x plus 1 into, that is dx, is equal to dt. Therefore I can write I is equal to integral, now 4x plus 1 dx, yes, dx 4x plus 1 dx is dt. So I can write dt by, this is root of 2x square plus x minus 3, that has become root of t. Let me continue it here. Therefore I is equal to integral t to power of half dt. So this is equal to t to power of half plus 1, sorry, this is minus half, so this will become minus half plus 1 by minus half plus 1 plus constant c. So this is equal to t to power of half by half plus c. This is equal to 2 t to power of half plus c. Now putting the value of t, we'll get I is equal to 2, t is equal to 2x square plus x minus 3. So I'll write here 2x square plus x minus 3 whole to power of half plus c. Right? Now let us go to the next problem. Okay. The next problem says is I is equal to integral 5x minus 2 by 1 plus 2x plus 3x square dx. Right? So let us rewrite this. I is equal to integral 5x square minus 2, and I'll rewrite the denominator in the standard form, 3x square plus 2x plus 1 dx. As explained earlier, we'll write, let the numerator, let 5x square minus 2 equal to a times d by dx of 3x square plus 2x plus 1 plus constant b. Therefore 5x square minus 2 is equal to a into 6x plus 2 plus b. Therefore 5x square minus 2 is equal to 6a into x plus 2a plus b. Now comparing the coefficients, this was 5x, not 5x square. Removing this square. Okay, so comparing coefficient of x and constants, sides. I'll have 5 is equal to 6a, right? Therefore a is equal to 5 by 6. Now I'll compare the constants. So I'll get minus 2 is equal to 2a plus b. Now a is equal to 5 by 6, so I'll write minus 2 is equal to 2 into 5 by 6. Plus b. So I'll get minus 2 is equal to 5 by 3 plus b. So b is equal to minus 2 minus 5 by 3. Therefore b is equal to minus 11 by 3. Therefore I can write 5x. Now I'll put the values here. So I'll get 5x minus 2 is equal to a into, that is 5 by 6, a into 6x plus 2 plus, that is minus 11 by 3. Right? Now I can rewrite this as I is equal to integral. Now I know 5x minus 2 is equal to 5 by 6, 6x plus 2 minus 11 by 3. So I'll rewrite it here. I'll write as 5 by 6 into 6x plus 2 okay, minus 11 by 3 whole divided by 3x square plus 2x plus 1, right, dx. Now I'll separate it out. Therefore I is equal to 5 by 6 is a constant, so I'll write outside the integral. So 5 by 6 integral 6x plus 2 divided by 3x square plus 2x plus 1 into dx minus 11 by 3 is a constant, so I'll take it outside, by 3 integral 1 dx by 3x square plus 2x plus 1. Okay, so now this is equal to 5 by 6 into I1 minus 11 by 3 into I2, where I1 is equal to integral 6x plus 2 divided by 3x square plus 2x plus Okay, now let us take the first part, I1. I1 is equal to integral d 6x plus 2 divided by 3x square plus 2x plus 1 dx. Now we know that the d by dx of 3x square plus 2x plus 1 is 6x plus 2. Therefore, let three x square plus 2x plus 1 is equal to t. Therefore, differentiating both sides, we get 6x plus 2 into dx is equal to dt, right? So we can rewrite I1 as now 6 plus 2 into dx is dt, so I'll write it as dt by t, right? So this is equal to log of modulus t plus c1. Now putting the value of t, let's put it as c1. So this is putting the value of t, I get this is equal to log of t is equal to 3x square plus 2x plus 1. So I'll write here x square plus 2x plus 1 plus c1, right? Now let us go to I2. Now I2 is equal to integral dx divided by 3x square plus 2x plus 1. Now, as we had done earlier, our first step should be to make the coefficient of x square as 1. Now, to make that as 1, I multiply and divide the denominator by 3. So, I will get this as integral dx divided by, I multiply by 3 and I also divide the whole thing by 3. So I'll get 3x square plus 2x plus 1 whole divided by 3 into dx. So now this 1 by 3 I can take it out because it's a constant. I'll take it out of the integral. So 1 by 3 integral dx by, now 3x square divided by 3 is x square plus 2 by 3 into x plus 1 by 3. Right? Now, the second step which I had mentioned was, now we have to add and subtract 1 by 2 into coefficient of x whole square in the denominator. So I will get 1 by 3 integral dx divided by x square plus 2 by 3 into x. Now I'll add 1 by 2 into coefficient of x whole square. So 1 by 2 into coefficient of x is 2 by 3. So into 2 by 3 whole square. Right? So that is 1 by 3 whole square. So I'll also minus 1 by 3 whole square. And I'll have to add 1 by 3. Right? So I'll get this is equal to 1 by 3 integral dx by, now this particular portion can be written as x plus 1 by 3 whole square. So I'll write this as x plus 1 by 3 whole square, and here I'll get remaining is 1 by 3 minus 1 by 9. So this is equal to 1 by 3 integral dx divided by x plus 1 by 3 whole square, right, plus 9, 3 minus 1, so I'll get 2 by 9. Now to make this in standard form, I'll write this as 1 by 3 integral dx divided by x plus 1 by 3 whole square, plus this I can 2 by 9 I can write as root 2 by 3 whole square. Right, now it is in standard form. So now what I do is let x plus 1 by 3 is equal to t. Therefore dx is equal to dt. Now I'll replace again I2 is equal to 1 by 3 integral dx, this dx is equal to dt, so I can write dt here, divided by, now x plus 1 by 3 is equal to t, so I'll get t square plus root 2 by 3 whole square. Right? Now I'll use the integral formula. Integral, I am writing it here for everybody's reference. So dx, integral dx by x square plus a square is equal to 1 by a tan inverse x by a plus c. So this is a standard integral form that I'm going to use. Therefore I2 will be equal to 1 by 3 Now a is, now 1 by a, 1 by a is into 1 by a. A is root 2 by 3. Right? Tan inverse, okay, x by a, that is t by a. A is root 2 by 3 plus some c2 constant. So this will give me 1 by root 2 tan inverse. Now I will put the value of t. T is x plus 1 by 3. So I'll write x plus 1 by 3 divided by root 2 by 3 plus c2. Okay, and we can just simplify it a little further. So I get 1 by root 2 tan inverse 3 into x plus 1 by 3 by root 2 plus c2. Now I know that I is equal to 5 by 6 into I1 minus 11 by 3 into I2. Now putting the values of I1 and I2, I'll get this is equal to 5 by 6 and I1 is equal to log of modulus 3x square plus 2x plus 1 and 4. The remaining part is 11 by 3 into I2. I2 is 1 by root 2 tan inverse three into x plus 1 by 3 or divided by root 2, and for c1 plus c2 I can write a constant c. Thanks children. I hope you all have found this class useful. In the next class, I will continue with integrals of some particular functions. Please like, share and subscribe to the channel to view more informative videos. You can press the bell icon to receive notifications whenever I post a new video. You can put your questions in the comment section below or email me at dlpbhatnagar@yahoo.co.in.